Hi, everybody. Welcome back from winter break. I'm a little bit grumpy, to be honest, about having to work again. But the good news is we have kind of a fun activity, at least to kind of cushion the blow. All that difficult work we did graphing various things before the semester ended is now going to enable us to graph the motion of a cam. So if we click right here on cam documents, you're going to see we have four different types of cams: the pair, the eccentric, snail, and regular hexagon cam. You guys can invent some other types too as you kind of look at these and get more ideas. Um, so we're going to make these with different diameters and we're going to test them out and we're going to see what motion they produce. That's going to help us answer the essential question, which is how do cams manipulate motion and forces, and how does the rock climbing gear hold you part excuse me, how does the rock climbing gear hold you when you fall? So we're going to start with the eccentric cam right here. So I'm going to go to inventor. Now, okay, sorry, this was a little bit left over. Let's go ahead and delete that. Let's not save that. Okay. So you can see I made an eccentric cam. I'm going to go ahead and just make another eccentric cam right here for us. The eccentric cam is a circle right here. And we're going to use a nominal diameter of 2 inches. So there we go, 2-inch nominal diameter. Let's take a look at our documents here and check out what the nominal diameter is. That's the overall kind of diameter of the cam, and then there's some other measurements that are based upon that. You can see like this one has 1/4 the nominal diameter, half the nominal diameter, and then radius equals half the nominal diameter. So you can kind of puzzle through some of those as you go through and build the pair cam, the hexagon, or the snail cam. Okay, so back to our inventor. Let's extrude it. If you look at the thing, it will tell you the depth is 3/16 of an inch. So we'll do 3 divided by 16 right there. And then we're going to start another sketch and we're going to put a little hole in there. If you look at these again, you can see there's a hole right there where kind of we're going to put a handle in and rotate it around that hole right there. So let's see. We're going to draw us a circle right here. And it doesn't really matter what the diameter of the hole is. I'm going to go with 0.25. I think that's going to work out just fine. And then for dimensions, I'm going to dimension the distance in between the center point of the overall cam and the center point of our testing circle right here. And I'm going to do the 1/4 of the nominal diameter. So 1/4 of 2. So we're going to do 2 divided by 4 right there, 0.5 inches. We'll finish the sketch and we'll do our cut extrusion right there. Going the other way, you can see the cut button is selected. Okay, perfect. Let's go ahead and save this. Oops, file, save, and we will save this as eccentric cam. And we're gonna just replace the old one. Let's go ahead and do that. Okay, now a couple of things we got to take care of before we're ready to actually do the testing. We have to set up some planes and an axis within this cam to kind of help us align with our testing setup. So we're going to click on plane and we're going to actually add a simple plane, which is the mid plane between two planes. So we have this one here and we're going to mid plane between the front and the back. And you can see that that put a plane right there in the middle. Okay, we're going to put in another plane that kind of goes this way. If you can kind of visualize that, it's going to cut right through the center of the cam here. A little bit tricky to put this one in. We're actually going to use a trick. We're going to use the offset from plane. And we're going to come over here to the origin and we're going to check like, okay, that's the XY plane, the YZ plane. The XY plane is the one that we want. And we could choose an offset distance if we wanted, right? And we could have it over here or there. But actually in this case, since we want it to go straight through the center, 0 is the appropriate choice. So there we go. 0 is the offset. Thank you, PLTW, for teaching me this trick right here. When you click on the cam, or pardon me, on the cam, when you click on the plane, you can stretch out the plane so you can see it a little bit better. Oops, don't move it. Don't do that. Yes, make sure you're looking just at the stretch out button. And there you go. And now let's see, let's add in one more thing, which is an axis that goes right through the center of the testing hole right here. Okay, so you can see we've put in now an axis going through the center right there. Okay, perfect. We'll stretch that out a little bit just for convenience sake. We'll save this one more time, pardon me, and we'll continue on here with our work. Let's go back to Google Classroom and take a look at something else. This is a zip file that contains a bunch of Inventor part files and an assembly which has been done for you. So this part file and assembly is what's going to be the setup for our testing. So if you go ahead and click on that and you download it, you'll open it up right here. Won't really let you do much here, but if you click download, it will download. I've downloaded this, I think 3 or 4 times today. That's all right. There we go. Okay, we have, failed network disconnected. Well, not such a big deal. I already have it downloaded earlier. Hopefully that won't affect our recording. We will see. So anyways, let's go here and take a look at the files that we just downloaded. If I click on this icon right here, the File Explorer, and I go to downloads, you can see a bunch of them that I've downloaded right here. Automata Simulation 1, 2, the original one. If I right click on this and I go to open with and I choose Windows Explorer right there, then you can go ahead and click and open it and you can see all those. You can see the assembly where we collect all of them together, the axle handle, the box, the follower, the guide, the cam test, and all of that stuff. Okay, so now what we have to do is we have to drag all of these into our Autodesk project folder. Okay, so we want them to be in our folder. I forgot to mention that at the beginning, that you want to make sure you're in your folder. So if you're not in your folder now, make sure to get in your folder. Again, right here, check under projects, make sure you're in the right folder. Okay, so back to this. How are we going to get all of these into our folder? What we're going to do is we're going to open up a new window right here, and we're going to go ahead and we're going to, perhaps you'll just have it in the quick access and you'll be good to go. But like me, if you don't have it there, you can go to documents and then go to Inventor and then choose your project folder. And then you can just drag each of these over here. And I did it once already, so I'm gonna just skip it, right? You can drag them over, or you can click shift and drag it over. One thing I probably wouldn't take is the this one right here. This is the project. This is sort of the project file that like gives it its name. You can see I already have my Mr. STEM project folder name. So I'm gonna go ahead and delete this one. I don't know if it will really do any harm, but we don't really need it anyways. There you go. So we've dragged everything into our project folder. So we should be all set now. If you have any troubles with that, ask your neighbor, ask me for help, and we'll get you sorted out. Okay, so here we go. Now what we're gonna do is we're going to go to open, and we're going to open up the Automata simulation. We'll click yes to update. And there we go. You can see kind of our test bed here. The first thing I'm going to do is kind of get rid of this gray box. It's good, but it sort of like gets in the way of viewing things and clicking on them. So I'm just going to uncheck the visibility right there, sort of get rid of that. We don't really use it for anything, so that's all good. So here we go. You can see we have some various parts here. We have the axle handle, we have the guide, which is this thing right here, and we have the follower. Okay, so what we're going to do is we're going to slide the cam onto this handle. We're going to spin the handle around, and we're going to observe the up and down motion of the follower. That's what we're going to do here. Okay, so to get our cam in, we're going to click on place, and we're going to place our eccentric cam, and we're going to click open. Okay, there it is. Now you can see it's kind of lined up the wrong way, right? It's in line instead of like being able to slide in. So what I'm going to do is I'm going to right click, and I'm going to go and I'm going to take a careful look at my axis, y-axis, z-axis, x-axis. I'm going to rotate the y 90 degrees like this. And there you go. Now I'm going to click once to place it. If I click twice, I'll place 2 of them. So I'm going to hit escape. So there you go. You can see I rotated it and then I placed it. So make sure to rotate it and place it correctly in your work there. Okay, so here we go. Looks good now. So I'm going to add some constraints now to kind of slide the cam into place for testing. So let's click on constrain, and we're going to do a mate right here, a mate constraint. I'm going to mate the center axis right here of the handle with the center axis of the cam hole like that. So we'll click apply. And now if I escape, you can see that I can move it and rotate it, and I can slide it in and out, right? But I can't, I can't pull it away from the handle right there. So we've added one constraint, but that's not enough. We need to add some more. So we're going to click constrain, and we're going to do a mate again. We're going to mate this to this. So that will slide it so that it is below the follower right here. We'll apply that one. And now let's test it out and see if it's working. Okay, so we spin it and the handle spins, but the cam does not spin with it. So we're going to have to add one more constraint right here. We're going to add a final mate right here between the handle work plane and this work plane. This is why we had to add in all these work planes right here. Let's click apply, and now we can spin the cam. Now the unfortunate thing is that the follower does not actually follow the cam. It just kind of stays in place while we spin it. So that's not good. That's not what we want to have happen. We're gonna have to apply another constraint here. So let's see, let's take a look at it. We need a constraint between basically the surface of the cam right here and the cylindrical bottom of the follower right there. So I believe the type that we need is a transitional constraint that will kind of allow the follower to move up and down this cylindrical surface to follow the continuous surface right here of our cam. Let's click that and let's apply it. And there we go. Now when we rotate this, you can see our follower moves up and down. And now you're kind of starting to get a picture of how you might collect data with this, right? Like there is position 0, and then as you rotate it up, right, it gets higher and then it gets lower. So we can collect data about the displacement of the cam or the motion of the cam, and we can start kind of thinking about how do these cams work and why are they so valuable. Okay, so there we go. We've done that. Okay, perfect. Now, this looks good, except we're missing one thing, which is a ruler to measure. So we're going to have to actually place in our ruler right here. We're going to go to place, and we'll go grab the ruler, open the ruler up. Now you can see we're going to have to rotate this again. I'm going to right click, and I'm going to rotate Y by 90 degrees. There we go. And then we'll click once to place it. Okay. Now let's take a look at this thing. Let's see kind of where it is in space. That's good. Not super good though. Okay, so I'm gonna do a free move and not a free rotate because I don't want to rotate it, right? It's already lined up the right way, but it's just not in the right position. So I'll do a free move here, and I'm gonna move it forward like that, and I'm gonna hit escape. So now it's sort of ahead of the cam, and I'm gonna click on the right button here. Then I'm gonna zoom in, and I'm gonna drag this right here equal in height to not to the follower itself actually, but to the base of the handle, right? So the 0 is right at the center line, the center axis of our handle. And let's click right again, and this should be good. Let's zoom in a bit. Yeah, you can see right here, those two are lined up, and this is right at a 1/2 inch, which is what it's supposed to be. Okay, perfect. So now what we're going to do is we're actually going to gather our data and we're going to record it. All right, let's say, oh, okay, let's just say yes to all. Sure. Okay. Hope for the best. Okay, so we've saved it. Now we can start gathering data. So what we want our data actually look like is this. We want to have right here, let's say degrees of rotation. And then we're going to do 0, 45, 90, and so on and so forth, and up until 360 degrees until we get back to 0, essentially. And then here, we're also going to have displacement of follower, like that. Okay, perfect. So at 0 degrees right here, you can see we're displacing the follower 1/2 inch. So I'm going to go ahead and type in 0.5 right here. Okay, now I'm going to go to 45 degrees, and we can take the reading like that. Okay, now the problem is I kind of have to estimate what 45 degrees is, and I can get a pretty decent estimate. But I can't get it perfectly. So what I'm going to do is I'm going to actually play with the constraints one more time here. Now let's see, I'm going to have to refresh my memory on how you do this. What we're going to have to do is we want to constrain the angle in between the handle and the follower. So I'm going to open up the follower, and I believe, yes, there's that one, and we should be seeing another mate. Yes, not that one. We should be seeing an angle of rotation for followers. So let's click on this, and let's make this visible right here. Angle of rotation follower. And then let's open up the handle, the axle handle right here. Work plane 1, okay, fine. Is that it? Is that good? Okay, I think that's good. And what I'm going to do is I'm going to do a constraint right here, and I'm going to constrain the angle between these two faces right here, this one and this one, to 0 degrees. We already did 0 degrees, so now we're going to have to do 45 degrees. Now, unfortunately, it looks like I might have to revise my work a bit for 0 degrees. If we look at it right here and zoom in, it looks like, did I do this right? Yeah, okay. It looks like we're right at 1.5 inches. So I'm gonna have to change this to 1.5. Okay, and now as I change this, we're gonna type in 45 degrees and we'll click apply. And there we go. Now we can take the reading. Let's make sure everything's lined up. Then we'll zoom in on it. Okay, so now this is measuring an 1/8 of an inch. So you can see there's 1 whole inch, there's 1 1/8, 1 1/4, 1 3/8. Where are we at? We're kind of in between 1 1/8 and 1 3/8. So I think it's closer. Now, I really wish we were doing this in centimeters instead of in inches. Maybe we could make like a centimeter ruler or something. Maybe that's something I could work on so we could estimate an uncertain digit. That'd probably be great, but not to matter here. Let's go with 1 1/8 of an inch. So 1.125. I'm going to record it in decimal form right there for 45 degrees. And then as we go here, we can just change this up right here. So you can see our 45-degree angle. We can right click. We can edit that. We can go with 90 degrees. Work. Yep, there we go, 90 degrees. Okay, now you can take the reading right there from 90 degrees and so on and so forth. Okay, I think that's it. I think that's enough for us to be able to make CAM and gather the data that we need. Thanks for watching the video. Good luck on your project.